Devoxx Belgium 2018. I'm really pleased to be joined here today by Lien and Jan-Kees. Welcome.
Hi.
Hi.
So you folks have been collaborating on a project which is about facial recognition using machine learning and other elements. How did it come about? And tell us a bit more about it.
Basically, I joined quite late, but the idea of the project is that we try to match speaker images, which have been collected all over the years on our Flickr website, the Flickr album of Devoxx, from I think 2007 or something like that. Lots of images, but are not tagged at all. Like, we don't know who's in this picture.
Yep.
But it would be cool if we did know that. But it's a hassle, so because you don't want to tag everyone, like, okay, this is Brian, this is Mark, this is all the people. Way too much work. So basically the idea came to use facial recognition and machine learning to do this matching automatically and make it easier. And make it easy to create a nice profile page and maybe thinking of further like GDPR and being able to give people data if they ask for that, or being able to remove the data afterwards. But first we need to have this metadata on the images to actually to have the information available so we can actually search.
Sure. Because from a Devoxx Belgium perspective, there are 2,000 images per year uploaded onto Flickr, maybe more, you'll be able to tell me. And one of the constraints with Flickr is that unless somebody is a Flickr member themselves, you can't tag them. And so there's a lot of anonymized images there. So that's a lot of images you've been searching.
Yes.
So tell us about the tech stack that you used to start doing this.
We used Tensorflow-Keras to do the machine learning and create a model. And I've been writing everything in Python. I also used the Google Cloud platform on a compute engine, had an instance running there, and it's connected to Google Storage, Google SQL. And for now, the proof of concept, I just wrapped Flask around my code to be able to do the APIs and to give back the JSON to front end.
So you're a machine learning expert as far as this is
concerned?
concerned?
No, not at all. I'm a final year student at University College of Erasmus in Brussels. And I did this actually as a final work subject. So
Which is awesome, right? Because with no prior experience with Python, TensorFlow and stuff like that, you can actually achieve quite a big result in a relatively short time at least. On a subject that would previously have been like a really expert subject, right? And like a thing you have to really study for to just get going. And basically Google in this case makes it really easy to do this. Yeah. They do the hard work.
Absolutely. I started off with having to Google TensorFlow because they gave me some pointers and I said like, you want to check out TensorFlow and Keras too, and I didn't know what it was. I was very excited about the subject, but that's how I started, just from zero.
So that shows that the barriers to entry are only in your mind to a large extent. You can actually get involved in these things.
Because I'm a student applied informatics, so I'm not a computer scientist. I don't understand all the mathematics behind it, but I don't have to. By just doing research and trying, I could actually develop the model that's nearly production ready very soon.
Yeah, well, production ready, but at least it works. The functionality is there. Yeah, yes. Exactly. Yeah.
So you must have hit some real challenges along the way. What kind of roadblocks were there?
Yes, there were quite a few. Well, first I realized I had to gather a lot of knowledge, so I started to skim all the information available to be able to find some structure and to find my way. I found out about a research paper, very deep convolutional networks in very large image. I forgot what is it? Image processing from Oxford University. Sorry, I repeat? Do you have to repeat it again? And they actually did a lot of work in creating this model VGG16. Which is referenced a lot, and I decided I wanted to try it because they gave the structure and the weights of this model that were available online. which means I wouldn't need to train a model, which was a bit of a worry, because it's a lot of work to get the whole data set. And there it was, so I started playing around with the code. I used OpenCV to do the facial detection, because there are two important bits. You need a good face detection something to detect the faces in an image, and then you need a good model to process those images and make good predictions. And the first block I had, it was that the facial detection wasn't good enough. In one picture, OpenCV only found 3 faces.
From 10 or something like?
From 10, and I started looking around, and then I found Google Vision, which detected nearly all the faces.
Okay, wow.
Yeah.
So
actually, the only face it didn't detect was a person looking downward.
Yes.
So it detected all of them, basically.
Okay, wow.
So I was very relieved with that, and since we were planning to move it to the cloud anyway, I only saw advantages there, because Google Vision can actually, if the images are stored on Google storage, you don't have to upload it to the cloud. It can simply process it in the cloud and sends me back the coordinates for the face, which I can process.
Okay, so how were you checking accuracy in terms of the results that you were getting back?
At first, manually, I did some image shows every time to show, like, okay, what is the results, to be able to be sure that it
But
was
still,
working.
it's really hard, right? I mean, an accuracy of 97 point something %. What does that mean? It can still be the wrong person.
Yeah.
So we had, for an example, we did some speakers like Brian and Stefan. And for example, Brian, the events where he was like recognized with a very high percentage. But just below that were a lot of people that don't really look like him, but they have some characteristics, like having a bit of a beard, being bald, and it detected them like with a very high accuracy, which is like an error. And then below that there was another picture of him. So why is this one low and is this one high, and are these guys between?
So
I don't know.
a lot of trial and error.
Yes, I also noticed that the speaker picture is very important, and that one is clear, because we used one from one of the speakers that I just plucked off the internet, and there was a kind of dark shade on his image, and the results are really bad. We were really worried that something was wrong with the model, but then Jan-Kees gave me a better picture of the speaker, and all the issues were solved.
Yeah, basically it detected everybody except him.
Yes,
Right, okay.
yes.
Okay.
So, and the second major issue that I had when using those trained model, it was trained for different categories. It was trained for categories of recognizing celebrities. So that's what's like, okay, I have to do some transfer learning, but then usability-wise, how many images would I need from a speaker to be able to retrain my model? I had no clue. How long would that take? And I kept looking, and then I found something like cosine similarity, and that's actually what we're using now.
So this is all about facial recognition at the moment. Could we use the same principles to search on other elements as well? And to search, how different is it to search on text versus facial recognition, for instance?
For text, I would actually also use Google Vision, because I read that you can do the same thing what I'm doing for facial detection. You can do Google Vision too. So.
Okay.
But basically you need a different model to do it.
Yes, you need a different model, but
yeah,
it's possible.
So what kind of use cases could you see going forward? I know the Devoxx use case, it's, as a Devoxx organizer myself, it's going to be so amazing to not have to trawl through thousands of images all of the time. And I think for the speakers themselves, it'll be great, because if we integrate it with Vox.com, they can go to their profile there, see all of the images, and they'll want to be able to use some of those as well.
It's easy to find now.
Yeah, absolutely. What other use cases can you really see that this project could be applied to?
Maybe detecting offensive material, something like that, well, like as being used on the tweet wall.
Yep.
Basically that's also a different model, but then again the ideas are the same, I think. That would be nice.
We can use because the speakers will be able to validate the pictures, and that information will be sent back to me. So we're going to create a second model, which will actually be retrained in recognizing the speaker, so it will get better over time.
Yeah.
A new speaker will be getting a first grouping, but then, yes.
Perfect. So you've got a Birds of a Feather session coming up this week?
Yeah, this evening.
This evening, actually.
And for anybody watching this at home that isn't at Devoxx and therefore hasn't been able to join, is there anywhere they can go and have a look at anything or learn more about the project?
The front end is on GitHub in a public repo. The back end is not, it's in Google Git
For now it's not, because it was a proof of concept, and I'm to be honest, we were quite time pressured, so I want to refactor my code, but I would like to put it on GitHub too.
That would be amazing.
For sure, open source.
And basically I think what you used was like the default tutorials from Google, right?
Absolutely.
On the image recognition and TensorFlow.
Yes, and existing frameworks and libraries that were also open source available, so you don't have to train the model yourself, you can actually plug the weights from the internet, create a model and just have a pre-trained model ready to go.
Definitely.
Yes.
Well, I wish you the best of luck with the BOF tonight. I'm sure that those sessions are great because you're going to have a developer audience there. They're going to be throwing questions and also throwing suggestions at you as well.
Yes.
So I'd love to hear how that goes. And good luck and well done.
Thank you.
Thanks.
Thank you.
Thanks for joining us.
Yes.